Let's go ahead and take a look at 12 factoring problems and operations on factoring. This is the same as the notes that I did in class and the same as a worksheet that has been posted on Blackboard for you guys. Let's go ahead and just take a look at these 12 problems, but a few of them may be different than what we did in the worksheet or what we did in class. But what I'm emphasizing here are there are a few key important concepts that I really didn't have time to go over in class, or at least I didn't have time to go over all of them. So let's take a look at our first problem. Now we're going to have to factor this, and I want you to notice right off the bat that it is in descending order, second power, first power, zero power, if you will, when it comes to the variables. But the highest power of x is a negative number. Now you never want that, so right off the bat I'm going to have to factor out a negative here. Then I want to look for a number that divides into 18, 51, and 36. 2 divides into 18 and 36, but will not divide into 51. 3, however, divides into all three numbers because the sum of the digits, 1 plus 8 is 9, 5 plus 1 is 6, and 3 plus 6 is 9. All three of those numbers, 9, 6, and 9, are divisible by 3, so therefore the original numbers are divisible by 3 as well. So first step, let's go ahead and factor out a negative 3. When I factor out the negative 3, that will leave me with a positive 6x squared, a negative 17x, and a positive 12. Alright, now we have two binomials that I'll have to factor from this one trinomial. Let's go ahead and just pull down my negative 3. And let's talk about the possibilities for the 6. First of all, that could either be 1 times 6 or 2 times 3. Either one would give us 6. It's really just a matter of guessing. So I'm just going to guess 2 times 3 because I think I've mentioned in class to you, I know myself and I know I tend to shy away from the 1 times 6. If you saw it once on a test, that would be the maximum that I would use the 1 as one of the factors. At least for the first term. The second term, that's a very distinct possibility. So let's go ahead and just use the 2 times 3. I'll put the 2 first and the 3 second. And of course I'm designing this so that the first times the first gives me the first term in my factoring. Now the signs. Notice that this is a positive 12. So either this could be a negative times a negative or a positive times a positive. Since I need this to be a negative, the only way I can get negatives is if both of these are negative. So in this case, let's talk about what it will both be negatives. Let's talk about what I could use for the 12. I could of course use 1 times 12. I could of course use 2 times 6. And I could of course use 3 times 4. Now you notice the problem here? 2 times 6. Those both have a factor of 2. I could not put either of those numbers in the first parenthesis here. It's not possible because both 2 and 6 have a factor of 2. This binomial would have a factor of 2 when no factor of 2 existed. It can't suddenly now exist. So I know that this 2 times 6 possibility is not a possibility, at least for this particular problem the way I've done it. So 2 times 6 can be eliminated. So let's take out the 3 and the 4. Let's check it out. Which one of those two numbers could go here? It frankly could be the 3 or the 4 you think, but please notice I can't put the 4 here because that would have a common factor of 2. And I can't put the 3 here because then I'd have a common factor of 3. It's got to be the other way around. The 3 has to go here, the 4 has to go here. So now let's go ahead, let me write that a little neater for you, and check our outside and inside. Notice again, I designed the first times the first to equal the first, the last times the last to equal the last. So the only thing I really have to check is if the outside and the inside combine to equal my middle term? Well, the outside, 2x times negative 4, would be negative 8x. My inside is negative 3 times positive 3 would be negative 9x. And when I combine those together, I do indeed get negative 17x. So there's my final solution. It won't factor down any further than that. Let's go ahead and take a look at our second problem. Now, first thing you need to look at, as always, is there is no common factor. It's once again a trinomial, so I need to split it into two binomials. Notice this time, though, I've got a fourth power on my first term. I could either split that into 2 and 2 or 3 and 1. Now, whenever you're doing this, the power has to be the same. So it has to be an x squared in both terms. And when I'm saying it has to be the same, I'm saying in regard to any trinomial. When you're factoring a trinomial into two binomials, the only way the outside and inside can combine in this way is if the powers are the same. So it's got to be split into x squared and x squared. It's the only possibility. Now you'll notice the next thing I need to do is the last term times the last term. That needs to be a negative, so one of these terms must be a positive and must be a negative. Now what could I use for 36? I could use 1 and 36, of course, but I've already kind of told you I tend to shy away from that one. It could be 2 and 18. Now I know that some of you are thinking, hey, there's a common factor of 2 here. But in this case, this is all right, because in neither spot where I would put the 2 or the 18 does the first term have a factor of 2. In fact, if you look at the coefficient back here, this understood 1, 2 is not a factor. Therefore, this is actually okay to have this repeated factor of 2 in both terms. The next term that goes into 36 would be a 3. So you could use 3 times 12. And I know you're noticing again, perhaps there's a factor of 3. For the same reason, that's perfectly acceptable here because there's no factor of 3 in the 1. So let's use 4 as the next one. It could be 4 and 9. 5 does not divide into it, but 6 does. That's the last possibility because there's no numbers left between these two. If I were to ask you the next biggest number that would go into 6, that number would be 7. 7 won't work, 8 won't work, but 9 would. But 9 and 4 would just be the reverse of what I had here. So when these numbers meet, when you've tried everything up to that point, there are no other possibilities. So there are really only 4 possibilities that I have to try here. And let's just start trying one. Just for the heck of it, let's try the 2 and the 18. At this point, you'll notice the inside and outside. I've got a 2x squared, a negative 18x squared, and when I combine those together, I do not get negative 5x squared. So I know that this cannot be the solution. And frankly, at this point, you just try things over and over and over again. You could next try, if you wish, the 3 and the 12. But this would give us 3 and negative 12, which would also not work. So we try the next one, 4 and 9. As a matter of fact, let me go ahead and write this one out a little more neatly. When you try the inside and outside, the inside gives me a positive 4x squared. The outside gives me a negative 9x squared. And when I combine those, I do indeed get the negative 5x squared. The problem is we're not done here. You'll notice that all of these factors are themselves perfect squares. This is x squared, this is 2 squared, this is x squared, and this is 3 squared. This is the sum, therefore, of 2 squares. Well, that's not a problem because, frankly, you can't factor the sum of 2 squares, so I just leave that one the same. Over here, however, This is x squared minus 3 squared. I can factor the difference of two squares, remember? So if I take off the squares, I have x minus 3. That's my first parenthesis. My next parenthesis is exactly the same as that, except you change the minus into a plus. And so this, therefore, would be my very original problem completely factored. And notice that I actually had to factor into trinomials twice. Just because you did one step does not mean you're done factoring. You always have to check and make sure that it won't factor anymore. And this one won't. These ones have no exponents on the x's. This is again the sum of squares, but the sum of squares doesn't factor. So now I am truly done. Let's go ahead and take a look at our next question. The next question is a little tougher. It looks very different. Now I want you to notice right off the bat that this one is not in descending order. Notice, by the way, that the powers, there's three variables on this. It's a power of 3 or an order of 3 if you want to say it that way. This also is an order of 3. There are 3 variables. And this is also a power or order of 3. So there's a tie here. So what you have to literally do is ask yourself alphabetically which one comes first. This one would be XXX, this one would be XYY, and the first one would be XXY. Alphabetically, which of these would come first? Well, to be honest, they all have an X initially. So there's still a tie for alphabetically which one comes first. So let's take a look at the second letter. Well, once again, we have a tie here for what comes first, but we do now know that this one, which is this guy, comes last. There's still a tie, though, between the first and the third. So we have to go clear to the third variable, if you will. And x comes before y, so this would be our first term, this one would be our second term, and this one would be our third term. So let's go ahead and write this in the proper order. 36x squared, oops, sorry. Oh no, I wrote that correctly, I'm sorry. Let me start over again. 36x cubed minus 84x squared y plus 45x y squared. Now, I know a lot of students will look at this and automatically want to factor out that negative. But the key here is, once it's in descending order, the highest power is not negative. The first term, if you will, in descending order is not negative, so we're fine. You don't want to factor out a negative here. But you do want to look for what term that all these numbers have in common. So let's go ahead and think about 2 for a second. Does 2 divide into these numbers? Yes, yes. Doesn't go into this one, so 2 doesn't go into all 3. Let's try 3 again. The sum is 9. That works. The sum is 12. That works. And the sum is 9 again. Well, that works. So they're all divisible by 3. Now, how about the variables? This one has an x. Actually, it has 3 x's. This one has 2 x's. And this one has an x. So they all do have an x. So far, it's divisible by 3 and an x. How about y? Well, this one's got 2 y's. This one has a y, but this one does not. Again, it has to be in all 3 terms to be able to factor it out. So that's all I can get out, I think, is a 3 and an x. So let's go ahead and take that out of my trinomial. Removing the 3 and the x leaves me with 12x squared. Dividing that by 3 would be minus 28. Taking out the x leaves me with 1x and a y. 3 times 15 would be 45. I removed my x, and that leaves me with 2 y's. Now I've got a trinomial. If this is going to factor, it's going to have to factor into 2 binomials. Well, let's talk about the 12 here for a minute again. That could be 1 and 12, but you know me, I tend to shy away from that one. It could be 2 and 6, and I know what you're thinking. 2 and 6, there's a common factor of 2. But once again, that's okay, because there isn't a common factor of 2 in the last term. So this is going to be perfectly okay. And the last possibility for 12 would be 3 and 4. You'll notice once again these numbers have essentially touched. There's nothing between 3 and 4. If I try the next highest number after 3 that does work, it turns out to be 6, and I already have that. So there's my only possible factors for the first term. Let's talk about the last term. Well, it could be 1 and 15, or it could be 3 and 5. Now, I know there's a 4 in between here, but I know 4 doesn't work. It doesn't go into 15. So essentially the numbers have touched, and I'm done. Those are the only possible factors for the second term. Alright, just knowing me the way I do, I probably didn't use 1 and 12 when I was designing this problem. So let's go ahead and try the 2 and the 6. I'll put the 2x in the first parenthesis and the 6x in the second parenthesis. And part of the reason I honestly want to try this one next is to show you why this is okay, even though there's a common factor of 2. Let's look down here for my common factor. It could either be 1 and 15 or 3 and 5. Again, I'm just going to randomly pick, and let's assume it's the 3 and the 5. Where do I have to put the 3? Does it have to go here or here? Better question is, where can't it go? And it can't go here. I can't put the 6 with the 3 because there'd be a common factor of 3 which did not exist here. So the 3 can't go here. So let's try it in the first parenthesis. And the second parenthesis, oh I'm sorry, that should be a 3y. And the second parenthesis would be a 5y, because my 3 times my 5 would be my 15, and my y times my y would give me my y squared. Well, I didn't do it first, and I usually do, but I should have talked about the signs. This is a positive 15, so either this is going to be a negative times a negative, or it's going to be a positive times a positive. How do I know it's the negative? Because I need a negative term here. So let's try this and see if it works. 3 times 6 is 18xy, and that'll be negative because I have a negative times a positive. Let's try this one. It's a negative times a positive, so it's a negative. 5 times 2 is 10xy, and that combines to be negative 28xy. It works perfectly. So once again, I have successfully factored this trinomial. Okay, let's take a look at our next one. This one's a binomial, so there's only 2 terms. If this is going to work eventually, if it's going to factor other than taking out a common term, it would have to be the difference of squares or the sum or difference of cubes. So let's take a look at this one and see what they have in common. What goes into 68 and 102? Well, 2 does. They're both even. How about 3? 3 goes into 102 because the sum of those 3 digits is 3, and 3 goes into 3. 3 won't go into this, so that doesn't work. So let's go ahead and think about the 5. 5 doesn't work for either one. 7 doesn't. If you try the rule, do you remember the rule? If I take off the last digit, the 2, and I double it, I get 4. And 10 minus 4 is 6, and 7 doesn't go into 6. And to be honest, I've really pretty much tried everything there is, so I don't see a common factor. So let's go ahead and just take out the 2, because I see that one. How about the variables? I'm going to take out a 2. How many x's can I take out? I've got 4 there. I've got 2 there, so I can take out at least 2 x's from both of them. I've got 2 y's here, and I've got 3 y's here, so I can definitely take out 2 y's. This one does not have a z, so even though this one does, I can't factor out a z. So let's go ahead and take a look at what we've got. When I take out the 2, I'm left with 34 x squared, because I'm going to take out my 2 x's, which will leave me with 2, and I take out my 2 y's, which doesn't leave me with any y's. When I take out my 2 here, I've got a 51, because 2 times 51 is 102. When I take out my 2 x's, I have no x's left. If I take out a y, I have 1 y left, and of course my z is left over. At first blush, it looks like I'm done, because it's not, first of all, it's the difference, but this can't be squares or cubes. And frankly, this looks like it could be squares, but there's no square root of 34. And there's no cubes anywhere in it, so it can't be squares or cubes. So it looks like I'm done. But I've made a mistake. And it's a common mistake that I'm going to see students make. You almost want to factor these down, numerically especially, before you do the problem. Let me look at this problem in a little bit more detail. If I factor the 68, that's 2 times 34. And if I factor the 34, that's 2 times 17. If I put them in order then, the 68 factors into a 2 times 2 times 17. If I think that the x is factored, I have 1, 2, 3, 4 x's multiplied together, and 2 y's. Now, obviously, you really didn't have to factor the algebra, but just for my purposes here, and generally speaking, you at least need to think of looking at it this way. So how about the 102? Remember we said 3 went into it because the sum of the digits is 3. Well, that's 3 times 34. 34, that sounds familiar. Remember I had that on the last one. If I keep factoring, it's 2 times 17. And if I put those in order, that would be a 2, a 3, a 17, and in this case I had 2 x's, 3 y's, and a z. Now let's talk about what we take out of each term. I can take a 2 out of each term. There's a 2. And the one I missed, I could take a 17 out of each term. I could take an x out of each term, another x, and that's it for the x's because I don't have any more left here. And remember, I said at the beginning I could only take out 2 x's because I only had 2 here and 4 here, so they both had at least 2. Here it's more obvious maybe to see what's going on. So let's continue on with this digression here. I could take out a y from both. That'd be a y. I could take out a y from both again, but I've run out of y's here. In fact, I've run out of variables altogether, so that's all there is. So once I take that out, what do I have left? I've got a 2. I've got 2 x's is an x squared. So that's all I've got on the second one. Let's take a look at the last one over here. What have I got left? First of all, notice it's negative, so I've got a negative 3. I've got 1 y left, and I've got 1 z left. And of course, frankly, you wouldn't write this factored out. You would say 2 times 17 is 34, x squared, y squared, and there's your answer. By the way, if you noticed at this point that both of these have a common factor of 17, which is very hard to notice without factoring, if you took out the 17, you'd be left with a 2x squared minus 3yz. And do you notice? That's exactly what I ended up with. The arithmetic, I've said this in class before, is actually harder than the algebra. I strongly recommend if the numbers get very big that you literally do consider factoring down the numbers just to make it easier to see the common factor. You don't have to do it with the variables. I think it's easier to see, but I think it's a good habit to get into, at least factoring the numbers down. One more thing I want to point out. Again, this did not continue on. You can always check your answer by multiplying out. 34x squared y squared times 2x squared does in fact equal 68x to the 4th y squared. And 34x squared y squared times my negative 3yz does indeed equal my 102 x squared y cubed z. So at this point, I really am confident of my final answer. Let's go ahead and move on to our next problem. Once again, only two terms. There is no common term. The only thing this first factor has, or this first term has, is x, and there's no x's in the second one, so there is no common term. This is either the sum of squares, or the difference of squares, or the difference of cubes. And frankly, you could think of it either way. If I think of it as squared, that means it's something squared minus something squared. Well, that would be x to the third squared minus 8 squared is 64. Y to the sixth squared is y to the 12th. But I could also think of it as something cubed, folks. I could think of this as the difference of cubes. This could be x squared cubed is the same as x to the sixth, and 4y to the fourth cubed would be the same as 64y to the 12th. And frankly, you never want to do cubes if you can help it. Cubes is kind of a last resort. If that's all that's there, you go ahead and do it. But you know what? It's much easier to do squares. If you want to see that worked out sometime, I'll be glad to do that for you, but I'm not going to take the time on this video. So how do I do difference of squares? Now that I've determined that's what I want to do, frankly, I just take off the squares, and that's my first parenthesis. X cubed minus 8x to the sixth. The other parenthesis is exactly the same, with one little change, a plus sign. So, I'm done. Well, not really. Not if you're paying attention. This is a multiple step problem again, folks. This is now a difference, but it's a difference of cubes. This becomes, or you need to look at it, like x cubed, of course, minus what cubed would be 8y to the sixth? Well, that would be 2y to the second. Similarly, this will be x cubed plus 2y squared to the third. I can factor both the difference of cubes and the sum of cubes. Well, it's pretty similar what those answers will look like, but let's go ahead and start. The first parenthesis, again, I just take off the cubes. So my first parenthesis is simply an x minus 2y squared. Now, this is how I do it. I just square this one, and I get an x squared. To be honest, though, you can ask yourself, the first times the first gives me the first. So x times x squared would be x cubed. And as was the case before, you could do the last times the last, but honestly, I just square this guy. And it's always positive, by the way. 2 squared is 4. Y squared squared is y to the fourth. But if you prefer, negative 2 times positive 4 would be negative 8. Y squared times y to the fourth is y to the sixth. Now I know I'm cramming it in here, but you need to have a middle term right here. This middle term is always the opposite sign. So if this is negative, that's a positive. And then I simply just take this times this, which would be 2xy squared. Now, don't forget, we got to do the second one, the sum of the cubes. Well, once again, I just take off the cubes. I'll do this one a little faster. I'm going to hope you saw it from the first one. And that's x plus 2y squared. Second parenthesis, a little bit bigger. It's a trinomial. Square the x, and I get the x squared. Square the 2y squared, and I get 4y to the fourth. It's always positive. Middle term's always the opposite sign, so if this is the plus, there is a minus. There's only ever one negative, folks. Either it's the second term in the second parentheses, or it's the second term in the first parentheses. But let's go ahead and finish the problem. My x times my 2y squared gives me a 2xy squared. Whenever you do the difference of cubes, folks, or the sum of cubes, this trinomial that you're left with will never factor, assuming that you took my advice at the very beginning and did the difference of squares first. That would be the only time that it's an exception. But generally speaking, sums of cubes, difference of cubes, your trinomial will never factor. Okay? Let's try an arithmetic problem just to be different here. And I know I said this in class, but I really mean it. Arithmetic is actually harder than algebra. Think about the way that you did these problems back in school. You probably were told to look for some cross cancellation. What goes into 34 and 85? Well, good luck finding that one. That's hard to see. Some of you I know are good enough to see that, but that's just impressive to me. Let's do it this way instead. How do you factor the 34? What goes into 34? Well, I hope you see it's an even number. 2 goes in 17 times. What goes into 38? Guess what? It's even again, so 2 works again. This time, 19 times. Times. What goes into 57? Well, 2 doesn't. It's not even. How about 3? 5 plus 7 is 12. 3 does go into 12, so 3 will go into that. Turns out to be 19 times. What goes into 85? Well, hopefully you see that 5 on the end. That's a dead giveaway that 5 goes into it. 5 goes into 85 17 times. Now the key here, folks, is to look for these. The same number on top and bottom. That's just equal to 1. And when you're multiplying and dividing, 1 does nothing, so you literally just throw it away. I can also, for the same reason, cancel the 17s. They don't have to be directly above one another. By the way, when you multiply, you literally could take this times this times this. It's almost like that stretches all the way across the top. So you could cancel the 17s. You can cancel the 19s. Everything canceled here, folks, except for the 3 and the 5. So my answer is simply 3/5. Factoring makes your work so much easier again. It's a real key whenever you have numbers, folks. I really recommend it. Let me show you why I mean that algebra is really easier. Take a look at this bad boy. I've got a W on the top. I've got 2 W's on the bottom. So 1's left over after I cancel. I've got a total of 4 X's, 2 here and 2 here, for a total of 4 X's on the top. But I only have 3 on the bottom. After I cancel, I'm left over with an X on the top. How about the Y's? I've got 4 here, 3 here, so 7 Y's altogether on the top. I only have 6 on the bottom, so I'll be left with a Y over on the top. Finally, the Z's are a little bit easier. I want you to notice that these are exactly identical. I've got 4 on the top, 4 on the bottom, so I'm done. But I do have these 2 Z's left over. So what's my answer? Well, all I left with on the top is an X times a Y. On the bottom, I am going to put it in alphabetical order always. I have a W and 2 Z's left over, and I'm done. Oh my gosh, is the algebra easier or what? Well, usually the algebra is easier. This one's a little trickier, but I'd like you to appreciate the fact that even though there's 4 things you're going to have to factor here, I've made sure that they're all pretty easy. I haven't made any of those really difficult ones that you had in class. But I also want you to notice that this isn't really a multiplication problem, it's a division problem. So what do? You multiply by the reciprocal. And if you want to be technical, I suppose you could take the time to copy this down, but you could frankly skip this step if you wanted to. Basically, I need to factor now. I really hope that you're starting to see that that's the difference of 2 squares. X minus 3 squared becomes x minus 3, x plus 3. If you factor this one down, I've got an x squared. It's going to be an x and an x. I've got a negative, so that's going to be a negative and a positive. I need the factors of 6. Well, it's either going to be a 1 and a 3. I'm sorry, a 1 and a 6 or a 2 and a 3. I'm going to give you a little trick of the trade, if you will. The guy that wrote the textbook, your teacher, everybody that designs these problems is looking for you to have common factors. I've got some 3's up here. Odds are I'm going to have a 3 down here. So I'm going to go with a 2 times 3. Now I want you to notice that I have a positive x as the middle term. That usually means the bigger one, the 3, will be the one that's positive, and the smaller one, the 2, will be the one that's negative. And that is indeed how this factors. So there's my first one factored. How about the second one? Well, there's 2 common factors here. 3 goes into both those numbers, and 5 goes into both those numbers. So if it's divisible by 3 and 5, 3 times 5 is 15. If you factor that out, I've got an x minus 2. How about the bottom? I've only got 2 terms. Once again, there's a common factor here. The 2 goes into both of those numbers. But more than that, do you see that they both have an x? So I got to take that x out also. When I take a 2 and an x out, I'm only left with an x in the first term. 2 times negative 3 would be 6. And of course, I've already taken the x out, so I'm good to go. 2x times this binomial, again, equals this binomial, correct? What can I cancel? Well, all kinds of things. Directly above each other, I have an x3 and an x plus 3. I've got the x minus 3s about as far apart as you can get them, but it doesn't matter as long as one's on top and one's on the bottom. Same thing with the x minus 2s. And all my binomials cancel. So there's my answer. 15 over 2x. Okay, stick with me here, guys, and camera lady. I only have a few left. Let's talk about addition and subtraction. You got to find a common denominator. Oh my gosh. I bet you didn't see that one too often in elementary school. Not one that difficult. What are you going to do? You're going to factor again. 18 factors into 2 times 3 times 3. 14 factors into 2 times 7. And 21 factors into 3 times 7. Now, here's the key when you're looking at factoring. I need a number that 21 divides into evenly. I'm just going to make up a number up here. Let's have 2 times 2 times 2 times 3 times 7, and 2 times 2 times 5 times 7 times 11. Is either one of those divisible by 21? I don't even know what those numbers are, to be honest with you. But is either one divisible by 21? Well, there's an easy way to tell. Because when you factor a 21 down, you get a 3 and a 7. The only way it's divisible by 21 is if the list contains a 3 and a 7. Let's take a look at the second list. It's got the 7. It doesn't have a 3. So I guarantee you it's not divisible by 21. Because to get 21, you'd have to divide by 3 and 7. Check out this first one, though. It does have a 3 times 7. So whatever my mystery number is, I guarantee you I could have divided by 3 times 7 or 21. See what's left over? I still don't know what this number is, but I know for sure how many times 21 divides into it. 2 times 2 times 2 is 8. And I know that if I multiply these factors together, I get an 8. If I multiply those ones together, I get a 21. And 8 times 21 is 168. But you didn't even have to know that to know how many times 21 went in. It's always the leftover factors. So let's go back to our problem. I need 18 to divide into this number. This number has to have, then, a 2, a 3, and a 3 on the list. Well, it also needs to be divisible by 14. It needs to have a 2 and a 7 on the list. Now be careful. It's already got the 2. I only need to add the 7. To be divisible by 21, it needs to have a 3 and a 7 on the list. Well, what do we need to add? Nothing. It already has a 3 and a 7 on the list. It has everything I need. So this is my common denominator, and that multiplies to be 126. So 126 is indeed my common denominator for all three. What do I have to multiply the 18 by to get the 26? Well, remember, here's your 18 times 7 is 126. So I multiply top and bottom by 7. How about the 14? Well, the 14 was the 2 times the 7. What's left over? 3 times 3, or 9. So I multiply top and bottom by 9. Finally, 21 was 3 times 7, times 6 would be 126. So let's see, that'd be 7 times 7 is 49, and I know 18 times 7 is 126. Remember, you have to multiply top and bottom by the same number because that's 1, and multiplying by 1 does nothing. So this is essentially the same value as 7/18, correct? 5 times 9 for the same reason would be 45. 6 times 11 would be 66. And when I add those numbers together, I believe I get 160 over 126. Now that's only half credit here, folks, because it can reduce. That's the right answer, it's just not reduced. Now I know you bright people are looking at this and saying, hey, I know what it reduces by because they're both even. Well, you know what? The only numbers you have to check are 2, 3, and 7, because those are the only prime numbers that go into 126. 2 goes into 160, you're right. But how about the 3? 3 won't. The sum of the digits is 7, so 3 doesn't go in. 7, I showed you the rule before, but double the 0 is 0. 16 minus the 0 is 16, and 7 doesn't go into 16, so 7 doesn't work. But the 2 does. I got to go ahead and divide top and bottom by 2. Top is 80. Now you can be clever on the bottom. You could just cancel the 2 out. What if you took it away? You'd be left with a 3 times 3 is 9 times 7 is 63. Little shortcut. Don't have to use it, but eliminating factors is frankly the same as dividing. So this, or canceling out the 2, same process. I know it's improper, but that's okay, and there's your final answer. Let's talk about how much easier it is to do the algebra. I need to have all these factors in my common denominator, so it needs to have an x squared and a y. It also needs to have 3 x's and 2 y's. Well, that's not enough x's. I got to tack on one more. I got to make that a 3. And I got to add on another y because it's got to have 2 y's. But that's not even enough y's because look at this last one. It needs to have 5 y's. So I need to add on some more y's. To be honest, there's even a better shortcut than that. What's the most y's you have? I've got 5 y's here. That'll be more than enough to cover the 2 y's that I need here. What's the most x's? I've got 3 x's here. Again, more than enough to cover my 2 x's. So as soon as I looked at that problem, I knew my common denominator would be x cubed y to the 5th for all 3 of them. So what am I missing from the first one? Well, I need another x because I need 3 x's. So let's put another x on there, top and bottom. And I need 4 more y's, right? So I'll put 4 more y's on the top and the bottom. And what does that give me? And I have not allowed myself enough room here, folks. I'm so sorry. I'm going to squeeze it in here. I don't really need this anymore, right? I've got 5xy to the 4th. Let's talk about the second one. Well, I've already got my 3 x's. I don't need any more of those. How about my y's? I have 2 and I need 5. So I need 3 more y's. How about my x's? I've got 1, I need 2, so I need 2 more x's. I'm so sorry. I'm so sorry I'm looking at the denominator. I need to be looking at the denominator. I've got enough y's, but I need my 3 x's. which would give me x to the fourth. Well, I'd like to get these in descending order. Which one of these terms comes first? Well, there's 5 variables on this one, 1 and 4 for a total of 5. There's only 3 here and only 4 here. So 5 comes first, then 4, then the 3. And there's my final answer. Oh boy, here we go. First of all, it's subtraction. Now, I never want it to be subtraction. I want to make it addition. So I'm going to do this to it. But now I either have to put the negative on the top or on the bottom. To be honest, most of the time you're going to end up putting it on top. Because when you write a fraction, it just looks better to say something like this than it does to say something like this. But this is the exception to the rule, folks. If I put this in descending order, which you're always supposed to do for factoring, right? Look what I get. My highest power of x is a negative. I don't want that. So what I'm going to do is I'm going to take that negative was on the outside of the fraction, and I'm going to move it to the bottom and make the whole denominator negative. Now that's going to switch all the signs, because I'm going to have a negative negative x squared. That's like that not x squared, right? It's not negative, it's positive x squared. But it's also not a negative, or excuse me, not a positive 2x, it's a negative 2x. When you distribute a negative, what you're in essence doing is adding one more negative to each one of those, which changes all the signs, always. If you don't like that, you can think of that as a negative 1 if you want. And negative 1 times negative 1 is positive 1, and negative 1 times a positive 2 is a negative 2. So now let's rewrite our problem, just to make this neat. I have a 5 over x squared minus 4x. Didn't make any changes there. Made that negative into a positive, because you never want to subtract. You make too many sign errors, folks. And then I took that negative down to the bottom, and I made this simply x squared minus 2x. Well, let's go ahead and factor. This will be a 5. And I'm going to factor out an x from both terms, which will leave me with an x minus 4. Plus 6. And I'm going to factor out an x from both terms again. I've got an x and an x minus 2. So what do I need for my common denominator? Well, it needs to have both factors. It needs to have the x and the x minus 4. It also needs to have both of these factors, the x and the x minus 2. Well, I've already got the x, folks, but I need that x minus 2. Which means this one's missing the x minus 2. I'll put it on the bottom and the top. Essentially multiplying top and bottom by the same thing again. There I've got the x, and I've got the x minus 2, but I am missing the x minus 4, so I got to tack that on as well. Now I want you to notice that the order doesn't make any difference. 2 times 3, 3 times 2, the commutative law of multiplication says you can do it in any order. They're both 6, so it's irrelevant. So let's take a look at this bad boy. This will be 5x minus 10. I'm going to try and squeeze this answer in here, over x times x minus 4 times x minus 2 plus 6x minus 24 over the same denominator again. 5x plus 6x is 11x. And negative 10 and negative 24, if you lose $10 at the crap table, you lose another 24, you've lost 34 altogether. All over your common denominator. And we're done. One more, folks, and we'll call it a day. This one's a little bit tricky, because I have 3 fractions, and one of them's a whole number. The only one with the denominator where you want to factor is this one. So this factors into x plus 6. Always look for that common factor, folks. It's going to be there so often. And x plus 2. So for this one, I don't have any denominator at all, so I don't need anything. For this one, I only need an x plus 6. I've got it right there. And for this one, I need an x plus 6 and an x plus 2. So if you see it, that's actually your denominator right there, folks. So I'm going to need an x plus 6 all up times x plus 2. Top would be exactly the same thing, right? Because it equals 1. This bad boy here, I've got my x plus 6, but I need to have that x plus 2. So I'm going to have to multiply top and bottom by x plus 2. Let me squeeze it in there for you. What does that give me? Well, for right now, I'm just going to write it this way. How about this last bad boy? And I apologize, I'm really squeezing this in here. First of all, it's subtraction. I don't want that. I want addition. The denominator this time was just fine. I don't want to put it down there. I want to take that negative through the top. So that's going to give me a minus x squared, a minus 10x, and a minus 16. My denominator, of course, it's the same thing. And I just noticed that I wrote this first one wrong. Let me go back and fix that for you. It was x plus 6 times x plus 2, right? Miscopy, mistake on my point. I make so many stupid errors, folks. I was just trying to point out how easy it is to make errors, right? You guys buy that. X times x, if I FOIL this out, is x squared. 2x and 6x is 8x plus 12. Well, to be honest, duh, we knew what that was when you multiplied it out. I could have just done it to begin with. Plus 6x plus 6x plus 12 minus my x squared minus my 10x minus my 16 all over the same denominator. I'm just going to squeeze it in there real quick. Let's combine my like terms. I've got an x squared and a minus x squared. 2 is the highest power. It goes first, but they both cancel. I've got an 8x and a 6x. I win 8 x's at the crap table. I win 6 more. I've won 14, but then I lose 10 of them. I'm left with 4 x's. Finally, I win 12. I win another 12. I've won 24. But then I turn around and lose 16. I'm sorry, yeah, so 24 minus 16 would be positive 8. And it looks like I'm done. But I'm not. Half credit though. It's equivalent, but you always have to check to see if it reduces. Let's factor the top. What's the common factor here? 4, of course. X plus 2. Copy my denominator. The x plus 2's cancel, folks. There's your answer. Now, I did this problem in class, and someone noticed, and I didn't let them get away with it in class. But this is always a good idea. They noticed that right off the bat, if you had factored this guy, that it factored into x plus 2 and x plus 8. And the x plus 2's would have canceled. Would have made the problem so much simpler, but I wanted to make the point that you always have to check when you get to the end. If I'd let him do this at the beginning, he wouldn't have had to do it at the end. You wouldn't have had that extra factor. So kudos to you, young man. I don't remember who it was, but nice job on that. That would have made the problem so much simpler. If you ever notice, do it. But again, part of my emphasis on this problem was to get you to check your final answer by factoring. I wanted you to do that, so I did the problem this way, which admittedly was longer. Well, that's it, folks. There's 12 problems there as examples. Hopefully you caught the key points that are in there that you haven't seen before. If you have questions over any of this, please come to my office hours, ask your SI leader, or of course you're welcome to come early to class or ask during the beginning of class on any day.